Welcome. Today we will see problem 2 on Bode plot. For unity feedback system, g of s is equal to 2 into bracket s plus 0.2s divided by s square into bracket s plus 1 into s plus 0.1s. Draw the Bode plot. Now we will draw the Bode plot of this function. Therefore, this is s plus 0.5 is there. Therefore, given equation g of s is equal to 2 into bracket s plus 0.25 divided by s square into s plus 1 into s plus 0.5. Converting above equation to time constant form. Therefore, time constant means what? We want 1 plus s term. Therefore, g of s is equal to 2 into bracket. This is s plus 0.25 is there. Therefore, we have to take 0.25 outside means 1 by 4. Therefore, 2 into bracket 4s plus 4 into 0.25 into 1 by 4 divided by s square into bracket 1 plus s. Already 1 plus s term is there. Therefore, no need to take any term outside. Into bracket 2s plus 2 into 0.5 into 1 by 2. We have taken 0.5 outside. 0.5 means 1 by 2. Therefore, which is equal to 2 into bracket 1 plus 4s divided by 4 into 1 by 2 into s square into s plus 1 into 1 plus 2s. Therefore, finally we get gs is equal to 1 plus 4s divided by s square into 1 plus s into 1 plus 2s. Therefore, this is our time constant form. We have converted the given equation into time constant form like this. G of s is equal to 1 plus 4s divided by s square into bracket 1 plus s into bracket 1 plus 2s. Now next step, identify the factors. Now here no coefficient, no value is there. Therefore, you can say that here coefficient 1 is there, that is 1 into 1 plus 4s. Therefore, k is equal to 1. Similarly, 2 poles at origin, that is 1 upon s square. This 1 upon s square term is there. It is known as 2 poles at origin. Similarly, 2 simple poles, that is 1 divided by 1 plus s and 1 divided by 1 plus 2s here. Now, and 1 simple 0, that is 1 plus 4s. Now, we are knowing that t1 is equal to 4 here. Therefore, omega c1 is equal to 1 by 4, which is equal to 0.25. That's why we have taken t1 is equal to 4, because this omega c1 is equal to 0.25. Similarly, omega here in this equation 1 divided by 1 plus 2s, t2 is equal to 2. Therefore, omega c2 is equal to 1 divided by t2, which is equal to 1 by 2, which is equal to 0.5 radian per second. Omega c2. And t3 is equal to 1, therefore omega c3 is equal to 1 radian per second. Because frequency should be increasing, 0.25, 0.5, 1. That's why we have given here omega c1 is equal to 0.25, omega c2 0.5 and omega c3 1 radian per second. Now we will write down magnitude plot table. Therefore, magnitude plot table, serial number, factor, resultant slope, start, end. Our first factor k is equal to 1, therefore 20 log of 1 to the base 10, therefore 0 dB. Starting point is 0.1, end point is infinity. This line is parallel to x-axis. Therefore, second, 2 poles at origin, that is 1 upon s square. 1 pole contributes minus 20 dB, therefore 2 poles will contribute minus 40 dB, therefore resultant slope is minus 40 dB. Starting point is 0.1, end point is 0.25. Now third, simple 0, that is 1 plus 4s. Simple 0 contributes the slope of plus 20 dB. Therefore, minus 40 plus 20 dB is equal to minus 20 dB. Its starting point is 0.25, end point is 0.5 radian per second. Now, next, simple pole, 1 divided by 1 plus 2s, it contributes a slope of minus 20 dB. Therefore, minus 20 dB is equal to minus 40 dB. Starting point is 0.5, end point is 1 radian per second. Another simple pole, 1 divided by 1 plus s is equal to minus 40 dB minus 20 dB is equal to minus 60 dB. Therefore 1 radian per second starting point and end point is infinity. Now this is magnitude plot. Now we will find out phase angle. Now phase plot, we have two poles at origin, that is 1 upon s square. Therefore it will contribute a phase angle of minus 180 degree. Second, one simple zero, that is 1 plus 4s with t1 is equal to 4. Therefore it will contribute a phase angle of plus tan inverse of omega t1. Now next, two simple poles, that is 1 divided by 1 plus 2s with t2 is equal to 2. It will contribute a phase angle of minus tan inverse of omega t2. Next, 1 divided by 1 plus s with t3 is equal to 1. It will contribute a phase angle of minus tan inverse of omega t3. Therefore total resultant angle is phi is equal to minus 180 degree plus tan inverse of omega t1 minus tan inverse of omega t2 minus tan inverse of omega t3. Therefore substitute values of t1, t2, t3 and for different values of omega from 0.1 to up to 10,000 we will find out the resultant phase angle. Therefore this is the for different values of omega phi is. Therefore substitute these values of omega in that resultant angle. Omega is equal to 0.1, we are getting minus 175. Omega is equal to 0.4 minus 182. Omega is equal to 1 minus 212. Omega is equal to 2 minus 236. Omega is equal to 4 minus 252. Omega is equal to 5 minus 255. Omega is equal to 10 minus 262. Omega is equal to 20 minus 266. I have taken these values. You can take different values also from 0.1 to up to 10,000. But values should be like this: 0.1, 0.2, 0.3, 0.4, 0.5 up to 1. After 1, 2, 3, 4, 6 up to 10. After 10, 20, 30, 40 up to 100. Like this. Therefore these are the different angles. Now we will draw the magnitude plot and phase angle plot. Both plot combination of both plots is known as Bode plot. Therefore this is our semi-log paper. Once again write down the equation on the semi-log paper. G of s is equal to 2 into bracket s plus 0.25 s divided by s plus 0.25 divided by s square into 1 plus s into s plus 0.25. Scale on x axis 1 centimeter. Scale on y axis y axis 1 centimeter is equal to 20 dB and on y axis again 1 centimeter is equal to 20 degree. And this on x axis these different values are there: 0.1, 0.2, 0.3, 0.4, 5, 6, 7, 8 up to 1, 2, 3, 4 up to 10, 20, 30, 40 up to 100, 200, 300 up to 1000. Therefore omega is equal to 1 and this 0 dB line, this intersection point is there. From to this intersection point, therefore draw the lines connecting to this plus 20 dB to this point, plus 40 dB to this point, plus 60 dB to this point, and again for below 0 dB minus 20 dB minus 40 dB. Therefore connect this minus 20 dB to this point, minus 40 dB to this point. Now angles are starting from minus 175. Therefore minus 160 minus 180 minus 200 minus 220 minus 240 minus 260 minus 280. Therefore these different angles are there: minus 175 minus 182 minus 212 up to minus 266. You can plot against these omega values. Therefore like this: minus 175 minus 182 minus 212. For different values of omega you have to see either at the top or either at the bottom different values of omega. Therefore connect these points by a smooth curve. Therefore this indicates phase angle plot. Now whatever this point is there, magnitude plot, minus 40 dB slope is there from 0.1 to 0.25. Therefore from 0.1 to up to 0.25 draw a line parallel to this line, therefore 40 dB up to 0.1 to 0.25. Then from 0.25 to 0.5 slope is again minus 20 dB. Therefore draw a line parallel to this 20 dB to this point, whatever this line is there. Therefore 0.25 to 0.5, again 0.5 to 1, slope is minus 40 dB. Again draw parallel to this line, and from 1 to infinity slope is 60 dB per decade, minus 60 dB per decade. Therefore draw a line parallel to this line from 1 to infinity. Therefore this is known as magnitude plot and this is known as phase angle plot. Thank you very much.